Okay, so day 5 is really just a continuum of day 4. So we're going to get into some tougher related rates now, or I guess I should say some more fun related rates. So here we have a conical tank with a vertex down. So I'm going to draw my conical tank with a vertex down. Is 10 feet across the top and 12 feet deep. And water is flowing into the tank at a rate of 10, and this, they're giving you a big hint, cubic feet per minute. So cubic feet per minute, if it's a feet cubed, that has to be a dV dt. Okay. Find the rate at which the change of the depth of the water, so I'm going to call this H, and then we have this R we're going to have to talk about. All right, so find the rate which the depth of the water, so that's that dH dt, is when the water is 8 feet deep. So I'm kind of labeling everything that they're giving me right now. Okay, so I know I need this volume formula. So the volume we said is the pi r squared times h 1/3 with the conical. Now, boom, 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 we have 3 variables. Oh no! Are any of them constants? We're like, please, please, please be a constant. Volume is changing, the radius is changing, and the height is changing, so we have no constants. So if I have 3 variables with no constants, then we need another trick. And the other trick that we're going to do is we're going to take this purple triangle. We're going to set it up what's called similar triangles. So this is H, this is R, and then they also gave me a specific one where H is 12, and be careful, R is 5. So we're going to set up a similar triangle for any H and any R. So if I kind of went through and said for any H and any R. You see how like these two are similar here? We have the same angles and going on. Okay, so we're just changing the lengths, but all of the angles is just a dilation. So this is similar triangles. So we're going to say for any H and any R, we're going to set up for this H and R. That's going to be the trick. So now I'm going to go ahead and cross multiply. 5 times H equals 12 times R. And then I have to decide what variable am I trying to get rid of? Well, this is where they said they're telling me DH, or they're telling me H and asking me to find DH dt. So R is the one that I want to replace. I don't want R there. So I need to go find what R is and put that in. Okay? So volume equals, I'm going to go ahead and write that pi over 3. And we said R is 5 over 12H. Whew, that looks gross. So let's see, that's 25 pi over 3 times 144 and then H cubed. I'm just going to clean it up a bit. Now, this is my other just little trick. And I'm not going to multiply that 3 because when I take the derivative and put it down, they're going to cancel. So now it's time to take the derivative. We've got it down to 2 variables. So we're going to take the derivative with respect to time. Remember I said when I bring the 3 down, they cancel? Okay. Now I can plug in everything that I know and solve. So I know dv dt is 10. I know h is 8. And then it is going to be completely up to you how much you are going to want to simplify this. If you decide to, it becomes 9 over 10 pi. But if it's a free response, you can leave it, but you might go ahead and practice for multiple choice. And then let's make sure we get our label. What was height in? So go read through, that's in feet. And what was time in? Time was in minutes, so that's feet per minute. Okay. The trough is 12 feet long and 3 feet across the top. The ends are isosceles triangles with altitudes of 3 feet. If the water is being pumped, so they've already kind of given me the picture and labeled, but now I'm going to read. If the water is being pumped into the trough at 2 cubic feet per minute, so that's going to be my rate of the volume. I see that that's a cubic feet. How fast is the water level rising? So let's maybe call this our height. Okay. How fast is the water level rising when it is 1 foot deep? So that's kind of what they've given me. Well, let's go write our volume formula. So volume is going to be, we need to get this triangle times the length, okay? So 1/2 base times height, so we'll call this our base, and we'll call this our length going on. Well, luckily we have some constants. I can see that my base is changing, and I can see that my height is changing, but this length is always 12. So I'm going to go ahead and plug in my 12 here. But wait, we have some things that aren't very fun. So we still have 1, 2, 3 variables. So I'm going to go ahead again, since I have the triangles going on, and use my similar triangles. So I can see here that I would have my basis to height as 3 is to 3. Cross multiply. And this one's kind of nice because B is just H. Now we're like, which one do we replace? So we want to keep H because that's what they've given me. So I want to replace the B. So volume is now 6, B is H, and H times H is H squared. Go ahead and finish this and see if you get 1/6 foot per minute. I think you can finish this one now. Okay. A construction worker pulls a 5-meter plank up the side of the building under construction by means of a rope tied to one end of the plank. So he's pulling this up. Polo, turn that down. Assume the opposite end of the plank follows a path perpendicular to the wall of this building, and the worker pulls the rope at a rate, right here, of this 0.15 meter per second. How fast is the end of the plank sliding along the ground when it is 2.5 meters from the wall. Okay, so what do we got going on? We got this stuff. We know this rate right here. We've got this guy, which is nice because he's a constant, kind of like a ladder. So which one are we going to be using? I'm going to use that Pythagorean theorem and call this x and call this y. So this is a constant, so I know I can plug it in. So it is not changing. So x squared plus y squared, you could say equals c squared, but again, we get to go plug that in before we differentiate. So equals 5 squared. Two variables, differentiate. The derivative of a number is 0. And now here's a nice little trick. The 2's will just cancel out. You can factor it, 0 over 2, they go away. Pythagorean theorem, that always happens. It's nice. So now we got to go figure out what we want. Okay, so I know I want to plug in when y is 2.5. I do not know my dy dt. That's actually what I'm trying to find. How fast is the end of the plank sliding along the ground? So that's what I'm solving for. My dx dt they gave me right here is a positive. We can see that's going to be a positive, but I know when I solve for this, that's going to be a negative. It's getting shorter. But this is a 0.15, and uh-oh, we don't know x. So I know that this was 5 and this was 2.5, so we need to go find that side using the Pythagorean theorem. Okay, so we need to go find x. X squared plus 2.5 squared equals 5 squared. X squared equals 25 minus 2.5 squared, and then we only want the positive square root of that. And I simplified it down. It's up to you if you want to, but I got 5 radical 3 over 2 that I'm going to now plug into this right here. So now I can see that dy dt is going to be the 5 radical 3 over 2 times 0.15, and I subtracted it over, divided by 2.5. And if you want to simplify, this is what I got. And it has to be negative, which we knew because that is a decreasing. So our rate is a negative. And let's see, y is in meters, and time was in seconds. Number 6, a 6-foot man walks at a rate of 5 feet per second away from a light that is 15 feet tall. When he is 10 feet from the light, at what rate is the length of his shadow changing? Ooh, so here's his shadow. In the shadow. Okay, so I'm going to give some things some variables. I'm going to call, let's go ahead and get another color. Oh, how about this one? I'm going to call this one x, and then we know that this is dx dt, and I'm going to call this one y. This right here is a nice, it's a constant. It is always 15. So for this equation, this is kind of crazy going on, but this is 2 different triangles. I have the big triangle. That was hard to see. And I have this little triangle. So I have two similar triangles. So I know that 15, that whole thing, is to x plus y, as 6 is to y. And there's so many different ways you could have set up that proportion. You could have said 15 is to 6, as x plus y is to y. There's lots of ways you could go set this up, okay? But whatever way you do it, now you need to cross multiply. And then I just kind of get my y's together. And now we've got it down. You can simplify it as much as you want. I'm going to go ahead because we just typically always solve for y. Why not? Why not? So there's my equation. These are actually really easy, and for some reason people miss them, but I love them and they're not bad. So just similar triangles to start. Okay, start the equation with similar triangles. So now we've got it down to two variables. We can differentiate. So part A says, at what rate is the length of his shadow changing? And I know that this guy, so we're looking for dy dt, and I know that the dx dt is 5. And this was in, y would be in feet per second. B says, at what rate is the tip of his shadow moving away from the base of the lamp? So it wants this whole thing. So B is asking, what is dx dt plus dy dt? So here I can plug in that my dx dt was 5 plus my dy dt and simplify if you want. So this 10 meant nothing, okay? That number is kind of useless for these. Two more questions. Okay, calculator aloud, here's an AP question. So this is the speed, so that's a rate, at which the car travels along a straight road, and the number of liters of gasoline used by the car is this. So this is an amount. So this would be the amount of liters, and this is a rate of kilometers per hour, just so we kind of see that. Okay, part B. Find the rate of change with respect to time, blank over dt, of the number of liters of gasoline used by the car when t equals 2. Okay, so we have this g equals, I'm going to go ahead, well, do I want, no, I'm going to leave it with 0.05x. Okay, so it wants it with respect to time. So dg over dt, and this is crazy because we've also got x's going on. So this is going to be a little trick that I'm going to just kind of talk you through. We are going to take and rewrite this like this guy right here. Okay? So right now, like all I did was say the dx's would cancel out and I'd have my dg dt. Because I'm trying to plug in this t equals 2 hours, and you see how I won't be able to do that with the g? I can't plug in a t. All I have are x's. So this is where we have to use this little trick of kind of breaking up of the differentials. So now, if I look at this, I'm going to go ahead and say what I'm looking for. So this right here is actually the same, this piece right here. That is like if I took the derivative of this piece. Okay, so that's like if I took the derivative of that right there. Agreed? So now I'm trying to find the dg dt when t is 2. So for this piece, I'm going to go math 8, okay, to find, actually, I don't even need to do that, do I? We can't math 8 it. So let's write what we need to do. We need to find g prime of 2 times dx dt when t is 2. Let's go plug that in here. So that's already right. Let's go plug in the 2. 120 times 1 minus e to the 4. So that gives me 120. So I know that this guy right here, this dx dt, when t equals 2, was 120. Okay, so I can plug that in right there for my dx dt. So now as I kind of think through this with my g prime of 2, 0.05, and then times the 120, and g prime, like that's going to be in liters per hour. And I would do that by kind of thinking through, this would be liters per kilometer, and this would be kilometers per hour, and then those guys can cancel. And feel free to simplify, 6 liters per hour. So that one's kind of a lot to think through. It was definitely a low scoring one. Okay, one more. This one's not nearly as bad, but we're going to use that same trick kind of on part C. So go ahead and do A and B on your own, and I'm going to let you check that you get these. Okay, so pause, work through those. Let me know if you need help with those, but I want you to go ahead and try them. And then we're going to look at C together. So over the time interval from 0 to 4 hours, the air temperature is a constant 32. At time equals 0, the wind velocity is 20 miles per hour. If the wind velocity increases at a constant rate of 5 miles per hour, I think I said meters, miles per hour, what is the rate of change of the wind chill with respect to time at t equals 3? Okay, so on part C, it's asking me for dw dt. But this one is in V's, not T's. So this is again where we're going to have to rewrite those differentials. So this would be dw dv, and then I'd have dv dt, because those would cancel to dw dt. Well, they told me a couple things going on. dv dt right here is a constant of 5. So I know that this guy is going to be 5 dw dv, just kind of rearranging. So now I need to actually find, I'm looking for this, at t equals 3, I need to find, that is w prime, well when t is 3, so let's go find v of 3. So v of 3 hours here at a constant rate of 5, 20, so 35. Number V of 0, let me just take you through, that was 20. So we started with 20, and then it's increasing by 5 per hour. So V of 3, if it's increasing at 5 per hour, it's increased by 15, which would give me 35. So we're actually looking for W prime of 35. I'm going to go ahead and math 8 that, multiply it by 5, and I get negative 0.892 degrees Fahrenheit per hour. Okay. All right, so that is the end of day 5. Some of those implicits and related rates, as you can see with the differentials here. And after that, we are going to start on just some fun things like L'Hopital, and the rest of this unit isn't too bad. So we just got through the hardest day today. Good job, you guys.